Welcome Algebra 1A students. We are working on a practice test here for topic 2 exponents. This is version 1 of the practice test. In this video we are looking at problems 16 through 25, the last page of this practice test. Our instructions for these next 4 problems for 16 through 19, we are to convert each number into standard form. Standard form is the regular way we write numbers. So this video, what I'm going to do is I'm going to interpret the exponents on the base of 10. So 2 times 10 to the negative 7th. A negative exponent I can think of as repeated division. So I could say we are going to start with the 2. We're going to divide by 10 7 times. So I'm not going to have space here to write this all out, but this is the idea. Start with the 2, divide by 10, divide by 10, divide by 10. We divide by 10 a total of 7 times. Every time you divide by 10, you might know the shortcut is the decimal point moves one place to the left. So 2, when you divide by 10, the result is 0.2. If you took that and you divided by another 10, it would be 0.02. If you divide by another 10, it'd be 0.002. So overall, we're going to divide by 10 7 times. That's going to move the decimal point to the left 7 places. Okay, so there you go. So every time you divide by 10, the decimal point moves to the left 1 place. We're dividing by 10 7 times, so move the decimal point 7 places to the left. So the decimal point really starts right there. That's one thing you got to remember with a whole number. So the decimal point is starting here. Every time I divide by 10, it moves left 1 place. So divide by 10 once, and it moves to the left of the 2. Divide by 10 again, and we got to fill in a 0. Divide by 10, let's see, that's twice, 3 times, 4, 5, 6, 7. And this is where the decimal point is starting. And when we multiply by 10 to the negative 7th, or divide by 10 7 times, this is where the decimal point would end. Okay. So one thing you want to do when you're trying to communicate with other people, this is great work to show, but remember, don't leave your answer like this. Write your answer clearly that this is, you can put a 0 to the left of the decimal point, but otherwise we have 6 zeros, decimal point and 6 zeros, and then a 2. So this is my answer. This is 2 times 10 to the negative 7th written out in standard form. Okay. Number 17, this is a positive exponent. So if I write this out in expanded form, I could say it's 6.8 times 10 times another 10. Positive exponent, just multiply by the base. Well, when I multiply by 10, the shortcut is the decimal point just moves once to the right. 6.8 times 10 would be 68, and 68 times the next 10 would be 680. That'd be it. I'd be done right there. I multiplied by 10 to the second, multiplied by 10 twice, 680, that's my answer. But if I want to use the shortcut, I could say, well, with that positive exponent, I'm going to move the decimal point right 2 places. So 6.8, this one's nice because I have the decimal point, that's where it's starting. I'm going to go, every time I multiply by 10, the result gets bigger. So 6.8 times 10 is bigger, it's 68, but I'm going to move it once to the right and then twice to the right. I got to fill in a 0. So this is where the decimal point starts, but right here, this is where the decimal point ends. So 680, then the decimal point if you need it, but yeah, 680. If you want to put the decimal point in, that's your choice. Okay. Number 18 is a positive exponent like number 17 was. So if you want to think about it, 2.78 times 10 once, times 10 twice, times 10 3 times, 4 times this one I can squeeze in. But again, every time I multiply by 10, the decimal point moves to the right. The results get bigger. So as just a quick example here, multiply by 10 once, that becomes 27.8. 2.78 times 10 is 27.8. Multiply by another 10, now you got 278. The decimal point is technically all the way on the right. I'm going to do this 5 times. So my shortcut is just going to be take that decimal point and move it to the right 5 places. So it's starting right here. I'm going to go 5 places. So 1, 2, 3, got to fill in a 0, 4, fill in a 0, 5, fill in a 0, and that's where the decimal point is going to end. It started here, it ends there. So again, write it clearly. we have a 2, 7, 8, and then 3 zeros. Don't need the decimal point. You can put the decimal point on the end if you want, but otherwise we don't need the decimal point. But that is 278,000. That is 2.78 times 10 to the fifth. Okay. One more for this section. We're back to a negative exponent. So a negative exponent tells me to divide. So 8.3 divided by 10, divided by 10. 4 times I'm going to divide by 10. I could write this one out. And I could start doing this division if I know the shortcut. Divide by 10, you move the decimal point once to the left. So 8.3 would become 0.83. Divide by 10 again, to become 0.083. And I could keep going, but again, I'm going to try to work smarter instead of harder. Use the shortcut here and say, all right, we're going to move the decimal point 4 places to the left. 4 places because the exponent's a -4. So we're starting with that decimal point between the 8 and the 3. We're going to move it 1, 2, 3, 4 places to the left. Here's where that decimal point's going to end, and I have to fill in zeros here. So again, you can put a 0 on the left if you want to, but otherwise 0 point, decimal point, we got 3 zeros to the right of the decimal point, and then our 8.3, and that is 8.3 times 10 to the -4th. Okay. Of course, I'm using kind of the shortcut about moving left and right here. If you want to remember, really the shortcut that I recommend students memorize is about positive exponent, negative exponent, not right and left, but big number, small number. And I'll write it out here. Okay, so there you see it. So if you have a positive exponent in scientific notation, standard form will be a big number. So we saw that with number 17. 17, we have a positive exponent. 680 is a big number. It's 10 or more. Number 18, we had a positive exponent. 5 was the exponent. We got a big number. 278,000 is a big number. Whereas if you have a negative exponent, like number 16, -7 was our exponent. Number 19, -4 was our exponent. Your standard form is going to be a small number, less than 1. So number 16 was 0 point something, 0 point all those zeros and a 2. Number 19, 0.00083. Those are small numbers. So if that helps you too, yeah, I don't necessarily recommend you memorize left and right movements, but positive exponent gives you a big number, negative exponent gives you a small number. Okay. All right, well, let's see what we can do here with 20 through 23. Now we're going the opposite direction. We're going to start with standard form, a regular plain number, and then we're going to convert into scientific notation. Okay. So looking at 20 through 23, thing to remember about scientific notation is scientific notation is written as a quote-unquote single digit multiplied by a power of 10. You can look back to the previous section, 16 through 19. Those all started in scientific notation. So I can see on the screen here right now, 18, 2.78, you might say isn't a single digit, but I go, but it's a single digit followed by the decimal point. Number 19, 8.3. You might say 8.3 is not a single digit, but it's a single digit followed by the decimal point. Single non-zero digit. So number 20, when I'm looking for my single digit, I go, let's see, not that 0, not that 0, not that 0, not that 0. Oh, 4, that's going to be my single digit. And then, but I need the 9 and I need the 0 in between the 4 and the 9. Okay, so 4.09. That's going to be my single digit. In my opinion, that's the easy part of this. You can agree or disagree. But now I need to figure out what's the power of 10. What's the exponent for 10? So the idea is, if you go back to the previous section, the exponent told us how many places the decimal point moved. Sometimes it was right or left, but it was ultimately, whether it was a positive or a negative. Number 18, exponent of 5, we moved the decimal point 5 places. Number 19, -4, we moved the decimal point 4 places, because we can't move it -4 places, but we moved it 4 places. So can I figure out how many places, if the decimal point is starting here, but I want it to end in between this 4 and the 0, how many places or how many digits is it moving? Well, if we count here, we'd have 1, 2, 3, 4, 5. We'd have 5 digits that we're moving. So that means the exponent is either a 5 or a -5. So that's the next thing to figure out. But I remember something from the previous section where we talked about a positive exponent gives you a big number, negative exponent gives you a small number. That works both ways. So if number 20, I would say that's a small number. 0.000 whatever 409, that seems like a small number. It's less than 1, which means I'm going to have a negative exponent. So we said we're moving the decimal point 5 digits, but because this is a small number that I'm starting with, I'm going to go with the negative exponent. So to put that all together then, 0.0000409 in scientific notation is 4.09 times 10 to the negative fifth. Remember too, I could kind of work backwards at this. I could say, let me take my answer. If I'm good going from scientific notation to standard form, let me take my answer. And let me see if I change 4.09 times 10 to the negative fifth. If I change that into standard form, would I get what I started with? And you might think to yourself, well, yeah, okay, this would be negative exponent. You could say we're gonna divide by 10 5 times. I'm not gonna write it all out here, but yeah, but that's gonna give me a smaller and smaller result. 4.09 divided by 10 is gonna be a smaller number. 0.409 divided by 10 again is gonna be smaller still. 0.0409. It's gonna keep getting smaller and smaller and smaller until when I divide by 10 5 times, I'm going to end up with what I started with there. So never a bad idea, in my opinion, to check your answer and say, what if I went from scientific notation to standard form? So what about number 21? So 21, again, if I start with that single digit, quote unquote single digit, I go, well, it can't be a 0, but I got the 9. All right, I need that 7. Okay, put the decimal point and then give the 7. The zeros I don't need. I don't have to say 9.7000. It's not wrong if you want to put the zeros, but it's just not necessary. Back here, this 0 was necessary because without that 0, it becomes 4.9. Not the same as 4.09. But these zeros on number 21, not necessary. Okay, so I got to figure out if this is where the decimal point is going to end, where is it starting? How many places do I move it? Well, this is 97,000. This is a whole number. So in a whole number, you might remember that the decimal point, it's not written, but it's really all the way to the right. So this is where the decimal point starts. This is where I want the decimal point to end. So how many places do I move it? 1, 2, 3, 4 places. So this is going to be either 9.7 times 10 to the fourth or 10 to the negative fourth. It's going to be one of those things. Well, I can do a couple things here to think. I'm going to go back to my shortcut to say, oh, this was a big number. 97,000, that's a big number. That means I want a positive exponent. So I'm going to take the positive 4 over the negative 4. So positive 4 there. But again, I could take my answer and I could think to myself, if I work backwards, if I start with 9.7 times 10 to the fourth, would I get 97,000? Well, this would be 9.7 times 10, positive exponent, I'm going to multiply by 10, times 10 times 10 times 10 times 10. And I go, yeah, this is going to keep getting bigger and bigger and bigger. 9.7 times 10 is 97, times another 10 is going to be 970. You keep going, eventually we're going to get to 97,000. Okay, so feels good, seems right to me. A couple more in this section, number 75. Let's see here. So again, what's the single digit going to be? Well, 7, and then I need the 5. All right, put the decimal point. Put the 5. 7.5. Again, my opinion, that's the easy part. But let's see here. Times 10 to what power? Well, let's see. This is another whole number, like number 21. So the decimal point is right here, and I want it to end right there. I'm just moving it one digit. So it's either times 10 to the first or 10 to the negative first. Well, again, if I think to myself, am I going to have the positive exponent or the negative exponent? Back over here. 75 is, I would say, a big number. It's bigger than 10. More than 10 is what I'm saying is a big number. So that means I'm going to have a positive exponent. Small number means less than 1. Less than 1 for the small number. So 75 is more than 1. It's more than 10. So I'm going to take the positive exponent. So 7.5 times 10 to the first And that one's easy enough to check because if you write that out in standard form, it's just 7.5 times 10. That's it. And you might know that. Yeah, that's 75. And that's what I started with. So 7.5 times 10 to the first, that's my scientific notation. Okay. One more in this section, 0.007, changing that to scientific notation. So again, single digit can't be a 0. So nope, not 0.007, not 0.07. No, it's going to be the 7. It's going to be just the 7. That's the only non-zero digit. I don't even need a decimal point in my answer here. Just 7 times 10 to what power? Well, let's see. The decimal point is really here on the 7. I don't need to put that in my answer, but that's where the decimal point is going to end. So how far am I moving it? It's starting here, and I'm moving it 1, 2, 3 places. All right, so move it 3 places. My exponent is either a 3 or a negative 3. And if you've been following along here with the shortcut, we've said this is a small number, 0.007, that's less than 1, so that's going to have a negative exponent. So I'm taking the negative 3 as my exponent. I don't need the decimal point on the 7. It's not wrong to have it there, but I'm just going to get rid of it because I don't need it. But yeah, that would be my scientific notation for 0.007 is 7 times 10 to the negative third. And again, not a bad idea if you want to think to yourself, well, multiplying by a negative exponent is division. So 7 divided by 10 divided by 10 divided by 10, that's going to get you smaller and smaller results. 7 divided by 10 is 0.7. Divided by 10 again is 0.07. It's going to work out there. Okay. All right, let's move on to story problems where we're doing the same thing. All right, you can read that story problem about New York City, but I'm looking at this number. I'm supposed to write it in standard form. So I just brought down kind of my shortcut here that I have a positive exponent in the 6. That's going to lead to a big number. Again, if you want to write this out, 10 to the positive 6, that's times 10 once, times 10 twice. I'm not going to write these all out, but I would keep multiplying by 10. And so the results are going to get bigger and bigger and bigger. Just multiplying by 10 once, that'd be 84.8. It's going to get bigger and bigger and bigger. So the trick is to move the decimal point 6 places. And since we're getting bigger, this is going to go to the right. So we're starting here. If I move it to the right once, now it's 84.8 we got. If I move it to the right twice, I got to do it 6 times. So 3 times, I got to fill in a 0, 4, 5, 6. This is where the decimal point is going to end. So again, make it nice for whoever's looking at your work, like your teacher, and rewrite it without those underlines or the waves or whatever. We got an 848 followed by 4 zeros. 1, 2, 3, 4. And there's our number in standard form. If you wanted to put the zeros in, or excuse me, not the zeros, the commas, that's 8,480,000. That's what that number is. Okay. Number 25. 25, we're going the opposite way. Again, you can read that story about the mass of the moon, how heavy is the moon, but in this case, we're starting with a big number. 73, oh boy, I don't even know how to say that number necessarily, but that's a big number. So I'm going to have a positive exponent. So what's the single digit? It's going to be 7.3, and then times 10 to some power. That's what I got to figure out. But I know this is going to be a positive exponent because this is such a big number, excuse me. So remember, this is a whole number, so really the decimal point is starting all the way on the right, and I need it to end in between. I don't know if I can squeeze this in, but I need it to end between the 7 and the 3. So I've already mentioned that it's 21 zeros. So getting here is 21 moves, 21 places with all those zeros. But then I got to get one more to get from to the right of the 3 to the left of the 3. So that's 20. Excuse me, did I say 24? 21 plus one more, that's going to be 22. 22 is going to be the exponent. It's a positive 22 instead of a negative 22 because this is such a big number. So I hope that video helped you. But yeah, see me in the next video.